In this video, I'm going to talk about limits. In particular, I'm going to give you an example using a function, how to find limits for that function. So let's consider this function, y is equal to f of n is equal to 1 over n. Here my n is an integer, particularly non-zero integer. N cannot be 0. As you can see, if you have n equal to 0, you'll be dividing by 0 here, 1 divided by 0, which is undefined. So my domain for this function is going to be non-zero integers. Just to give you some examples, so it could be 1, 2, 3, etc., or it could be -1, -2, -3, etc. Now let's go ahead and kind of investigate the behavior of this function as n gets bigger and bigger and bigger. So that means as n gets from 1, 2, 3, 4, although it keeps going, right? So let's create a table. As you can see in this table, as n gets bigger and bigger, so we start with n is equal to 1, function is 1, like f of 1 is going to be 1 divided by 1, that is 1. N is equal to 2, the function value is f of 2 is equal to 1/2. N is equal to 3, f of 3 is equal to 1/3. Similarly, n is equal to 4, f of 4 is equal to 1/4. As n gets bigger and bigger and bigger, what happens to the function value? It gets smaller and smaller and smaller. For example, you can see it starts with 1, then it gets to 1/2, 1/3, 1/4, and if you keep going down, it's going to get smaller. Let's say, for example, n is equal to 10, it's going to be 1 over 10, right? For n is equal to 100, it's going to be 1 over 100. So these numbers or the function values are getting smaller and smaller and smaller, and it is approaching a value. What value is it approaching as n is getting bigger and bigger? It's approaching 0. Okay? It's getting smaller and smaller and smaller, and it's becoming closer to 0. So let me give you an example here. This is your favorite number line. You started at 1, then you get to 1/2, then you get to 1/3, then you get to 1/4. You can get as close to 0 as you wish. You can get as close to 0 as much as you want by making your input n bigger. So ultimately, what is happening is this. As n gets bigger and bigger and bigger, the f of n gets smaller and smaller and smaller. And in the limiting case, or in the ultimate case, as n races towards infinity, positive infinity, f of n races towards 0. Keep in mind, however, here that for no value of n, again, for no value of n, doesn't matter how big it is, f of n is going to be exactly equal to 0. Okay? For no value of n, f of n is ever going to be exactly 0. But you can get arbitrarily close to 0, as close to 0 as you wish. This concept is very important. Okay? You can get arbitrarily close to 0, as close as you wish. So in the limiting case, as n gets towards infinity, f of n gets to 0. And this concept is called the limit. So limit n approaches infinity, f of n is equal to 0. Now let me consider the other scenario. What happens if fn goes towards negative infinity? So I'm going to start off with n is equal to -1, n is equal to -2, and n is equal to -3, and it keeps going. It races towards negative infinity, meaning n is getting smaller and smaller and smaller. And let me go ahead and create a table for this one as well. As you can see in this table, how the function value changes as n gets smaller and smaller. So for example, n is equal to negative 1. I'm going to get negative 1, as you can see here. N is equal to negative 2. I'm going to get negative 1 half. Just plug in negative 1 half, negative 2 in the function. And similarly for n is equal to negative 3, it becomes negative 1/3, and similarly it keeps going. Now let's again draw our favorite number line. What's happening this time? So let's say this is my 0, and this is my negative 1, and that's my negative 1 half, and that's my negative 1/3, that's my negative 1/4, and let's say that's my negative 1/5. So these numbers, if you look at this sequence of outputs or sequence of function values, you start from negative 1, negative 1 half, negative 1/3, negative 1/4, negative 1/5, and it keeps going. Now, if you look at these numbers, what is happening here? Again, it is approaching the value 0. But this time, as opposed to function values approaching 0 from the right hand side, in the last case right here, this time it's approaching 0 from the left hand side. So please make that observation. Function values approaching 0 from the right hand side for positive infinity, and function value approaching 0 from the left hand side for negative infinity. And you can see this sequence is increasing. So here I kind of want to make a point. These numbers are increasing, by the way, getting bigger and bigger and bigger. And a common mistake, and I have to admit that I'm guilty of that as well, is this. We tend to think as numbers get closer and closer to 0, that means it's getting smaller and smaller. However, in this case, in this sequence of numbers, is just the opposite. The numbers are getting bigger and bigger and bigger. Negative 1 half is bigger than negative 1. Negative 1/3 is bigger than negative 1 half. And negative 1/4 is bigger than negative 1/3, and so on and so forth. So, as n approaches towards negative infinity, f of n approaches 0. However, it approaches 0 from the left hand side. So in the limiting case, in the extreme case, okay, what happens to the function f of n as n races towards negative infinity is the value that we are interested in, and that is the value we call to be the limit of this function as n approaches negative infinity. And similarly, we write it like this. This is the notation that we use: limit n approaches negative infinity, f of n is also 0. So just to summarize things, so we found two limits. One is as n approaches positive infinity, what happens to the function? We notice that as n approaches positive infinity, the function approaches 0, or the limit of the function f of n as n goes to positive infinity is 0. And similarly, the limit of the function f of n as n goes to negative infinity is 0 as well. However, the main distinction is this. As n goes to infinity, positive infinity, the function approaches 0 from the right hand side. As n goes to negative infinity, function approaches 0 from the left hand side. In the first case, as it approaches from the right hand side, the sequence of numbers 1, 1 half, 1/3, etc., it's getting smaller, smaller, and smaller, and ultimately approaching 0. On the other hand, as n approaches negative infinity, the sequence of numbers that's getting closer and closer to 0 is increasing. That means from negative 1/2 to it goes to, from negative 1 to it goes to negative 1/2, negative 1/3, and this sequence keeps going. Ultimately, it approaches towards the point 0. Ultimately, it approaches, doesn't go or doesn't reach the point 0. It approaches the point 0. And this ultimate or limiting case is called the limit of this function. I hope that this discussion was helpful. Thank you very much.